We finally saw a black hole. In 2019, scientists captured the first ever image of one, a glowing ring of fire surrounding a dark void. But that was just the beginning. Since then, we've uncovered shocking new facts about these cosmic giants. Black holes aren't just the universe's most destructive forces. They may hold the key to time itself. Some grow as large as 66 billion suns. Others rip apart entire stars in seconds. And the strangest part? They might not be as inescapable as we once thought. This is everything we know so far, backed by hard science, real numbers, and the latest discoveries. Let's get into it. The idea of black holes isn't new. In fact, the concept can be traced back to 1783 when English scientist John Michell first proposed the existence of dark stars with gravity so strong that light itself couldn't escape. But it wasn't until Albert Einstein published his general theory of relativity in 1915 that the mathematics of black holes truly began to take shape. Then, in 1916, Carl Schwarzschild found a solution to Einstein's equations that described what we now call a Schwarzschild black hole, a simple, non-rotating black hole. For decades, black holes remained theoretical, an idea that scientists debated but had no way to observe directly. That changed in the 1960s when John Wheeler coined the term black hole, and Cygnus X1, one of the first suspected black holes, was discovered using X-ray observations. Fast forward to 2019, and history was made when the Event Horizon Telescope captured the first ever image of a black hole in M87, revealing a glowing ring of superheated gas surrounding an empty void. So how do black holes actually form? The most common way is through the death of massive stars. When a star at least 20 times the mass of the Sun runs out of fuel, it can no longer produce energy to fight against gravity. The core collapses in a violent explosion known as a supernova, leaving behind an ultradense core that forms a black hole. There are also supermassive black holes, which can contain millions or even billions of times the mass of the Sun. These giants sit at the centers of galaxies, including our own Milky Way, with a supermassive black hole, Sagittarius A*, lurks, about 27,000 light-years away. Interestingly, astronomers have also identified a third category, intermediate mass black holes, which range between 100 to 100,000 solar masses. These are harder to detect, but some promising candidates, like HLX, one in the galaxy ESO 243-49, have been found. If you fell into a black hole, what would happen? The first thing you'd notice is spaghettification, a real scientific term describing how intense gravity stretches and pulls objects apart. Closer to the event horizon, time slows dramatically due to gravitational time dilation, a phenomenon predicted by Einstein's relativity. Beyond the event horizon lies the singularity, a point where density and gravity become infinite. But here's where things get truly bizarre. Quantum physics and general relativity don't agree on what happens inside. Some theories suggest black holes could lead to wormholes or even parallel universes. For a long time, black holes were seen as cosmic vacuum cleaners that only swallowed up matter. But recent discoveries show they also shape galaxies and trigger star formation. When matter falls into a black hole, it releases enormous amounts of energy, sometimes forming quasars, the most powerful objects in the universe. Take TON 618, a quasar powered by a black hole with a mass of 66 billion suns, one of the largest black holes ever discovered. It emits more light than 100 trillion stars, proving that black holes can actually create and sustain galaxies rather than just destroying them. Another groundbreaking discovery in recent years is gravitational waves, ripples in space-time caused by massive objects colliding. In 2015, the LIGO Observatory detected the first-ever gravitational wave signal from two black holes merging. These ripples confirmed a key prediction of Einstein's relativity and opened a new window into the study of the universe. Since then, LIGO and its counterpart Virgo have detected dozens of black hole mergers, revealing surprising facts. like the existence of unexpectedly massive black holes, some exceeding 85 solar masses. Here's where things get really strange. According to quantum mechanics, information can never truly be lost. But if something falls into a black hole, where does its information go? This is known as the black hole information paradox, first proposed by Stephen Hawking. Hawking initially suggested that black holes could evaporate over time through Hawking radiation, eventually disappearing completely. But if that happens, where does all the information go? Physicists have been debating this for decades, and new research suggests information might actually be encoded in subtle ways within the radiation itself. Some scientists have proposed that black holes could be gateways to other dimensions. The Einstein-Rosen bridge, or wormhole theory, suggests that black holes might connect distant parts of the universe. While this idea remains speculative, it's been a popular concept in science fiction, and some researchers are actively looking for signs of exotic matter that could stabilize such a structure. With new telescopes like the James Webb Space Telescope and upcoming projects like the Einstein Telescope, scientists are poised to learn more about black holes than ever before. Future discoveries might rewrite our understanding of space, time, and gravity itself. Black holes could hold the key to the deepest secrets of the universe. Could they teach us about the true nature of time, the origins of the cosmos, or even hint at the existence of parallel worlds? One thing's for sure, this is just the beginning of our journey into the unknown. If you want to keep exploring the biggest mysteries of space, make sure to like, subscribe, and turn on notifications for more mind-blowing content. And tell us, what's the most fascinating thing about black holes to you? Drop it in the comments.